Hello everyone, welcome to watch our demo video. We created an innovative technology for programmers to do customized analysis and reporting. For example, building complex tables. Our patent-pending PDR technology is using a unified approach to generate tables and reports across different programming platforms and file types. In the first part of the video, we will show you how to produce a simple world report from scratch in R using RepTik analytics solution. We will work on some dummy healthcare data consisting of 500 patients with age, sex, diagnosis, a disease score, and a lab test. Like the common practice, we have a project folder structure for hosting data, results, shells, and report outputs separately. In the report, we will build a descriptive table showing distributions of the age and sex for the CVD1 and CVD2 patients separately. Let's make the shell report first. We insert the empty table here. Now we will add the attributes and headers. So it looks like this. Then we would like to apply some formats like this. So here is the RepTik interface with the folder paths. RepTik will automatically produce the presentation data referencing structure, the PDR, according to the rows and columns of the shell report table. So we add tag. Now the PDR structure was generated. We will move this into the shell file. We now start the coding in R. First, we set the result output txt file, assign the table name T1. We select the age and sex data for the CVD1 patients. We assign value 2 to variable cc, which stands for the column of the CVD1 group. So we use the RepTik function txt_string to output the total n for this group. The row value is 2. We use the RepTik function txt5start to generate the mean SD for age. The row value is 3. Then we use the RepTik function txt3cp to generate the count and percent for sex. The row value is 4, and we select sex value equal to 1 for male. For group CVD2, we will repeat the same, only updating the input data, and the column now is 3. Now let's run the code. We can see that one result file T1 was generated. Now we can inject the results into the shell report containing the PDR with RepTik. As you can see, we produce the table and the report with no need to program any layouts and formats here. Next, we will show you how to modify and scale up to build complex tables. Based on this earlier shell layout, now we would like to add the median and IQR for the age. We also want to know how many patients have age above 75 for the count and percentage. Now, instead of male, we would like to see female counts. Further, we would like to add distribution of the lab tests. And then we would like to separate this group CVD2 into the two subgroups. So here we have the updated table. The layout seems a bit tight. Let's add some empty rows and maybe change it to another layout style. Now we want to indicate how the values are displayed. We will add some paragraphs of report descriptions and put some results in the description. We want to add a logo to the report. Now we save the shell and adding the presentation data referencing structure. Now the PDR structure has been inserted into the table. We also put the PDR structure into the paragraphs. We move the output to the demo shell, and now we will update the R code. For comparison, we will put the code below. We will use the same result output txt file and the table name T1. We copy the code. For group CVD1, we need to include the lab data as well. CVD1 is still in the column 2. Count of total patients remain the same, no change. For age, the row was shifted by 1, so it is 4. We add the median IQR parameter to the txt5start. We use the RepTik function txt3cp to generate the count and percent for the age above 75. The row value is 6. For sex, the row value is now 8
and we will select sex value equal to 2 for female. Then we will use the txt5 start function to calculate mean SD for the lab test. You may actually find out that for this block of code, we only need to update the input data DF group and the column CC for the different patient groups to produce the results. So we can simply wrap this block of code up as a project-specific function for scaling up the analysis. Now we will call this function to generate results for all the different groups. This is CVD1, column 2, and then group CVD2A, column 3, and CVD2B, column 4. Let's run the code. Inject the results into the shell. Okay, we have the updated report with a more complex table and a lot of changes. And we also have the values in the text as well. So with RepTik, the whole process is very efficient. You have no need to program the tedious report file layout and formats. For the complex table, you can easily modify it on the go. No need to use LaTeX or R Markdown. You can concentrate your energy in doing the analysis and getting the results. And further, the programming with RepTik functions is very intuitive and flexible. Last but not least, our technology is scalable to multiple platforms like SAS, Python, SQL, and multiple report file types like Excel, PowerPoint, and OpenOffice documents. Want to know more about RepTik? Reach out to us.